See, we have discussed periodic motion. Okay, periodic motion is basically when the motion repeats itself into the fixed intervals. Okay, that is periodic motion. And periodic motion is of many types, in which one of the type is oscillation and vibration. Okay, oscillation or vibration, when anything does to and fro motion. Okay, to and fro means along a mean position, then that kind of motion is called what? Oscillation. Okay,
Okay.
Kevin, that is oscillation. And all oscillations can be periodic motion, but all periodic motions cannot be oscillatory. Okay, tell me two examples of oscillatory motion, and one examples of oscillatory motion and one example of periodic motion. Tell me, Kevin.
Periodic motion is like the spring with the mass.
Yeah, spring is periodic motion, and oscillatory. Spring is
That's
oscillatory motion or periodic motion or both?
that's periodic motion.
Periodic motion. And spring motion is not oscillatory.
It's not spinning, so it's not oscillating.
Spinning, oscillation. What oscillation has to do with the spinning?
Like when it's oscillating, the object has to be like rotating, right?
So oscillation has to do with the spinning? That's what I'm right. Rotation and spin is nothing to do with this periodic motion. What is periodic and what is oscillatory motion? Can you differentiate it?
So periodic motion is like the oscillation is a type of periodic motion.
Yes. Oscillatory motion is a type of periodic motion. Means it is one of the part of the periodic motion. Getting my point?
Yeah.
It is one of the part of the periodic motion. What is the specific about oscillatory motion?
Like
Yes.
the object has to like spin.
That's what I said. The type of motion I have told you, to and fro motion. It's not spin, Kevin. I haven't like anywhere I haven't named anything spin. Suppose this is the mean position, right? Okay,
Yeah.
and this has to go this side and this has to go this side. Okay, means it has to go this side and then again came back, then it has to go this side and then again come back. This is a kind of oscillatory motion. Have you ever seen pendulum?
Yeah.
Have you ever seen the pendulum in the churches? They have the pendulum like this. It goes this way. Okay, then again came back to the mean position, then goes to left extreme position and then came back again to the mean position.
Yeah.
So this is the type of motion called to and fro motion. What motion? To and fro. I have written the name here. To and fro motion. Okay, to and fro motion, you are going ahead and then you're coming back and then you are going back. Getting my point?
Yeah. Okay.
So sine wave motion or cosine wave motion is a periodic motion. Okay, because they are fixed. Their motion is same in the fixed intervals. Like 0 to 2 pi is the same, 2 to 4 pi is the same, right? So sine wave
Yeah,
and
okay.
cosine wave is a periodic motion. But pendulum, spring, these are the motion of which type of motion? These are the oscillatory motion. Why? They are the type of periodic motion. They are also periodic motion, but they are doing to and fro motion. So they are oscillatory motions as well. Oscillations. Got it?
Yeah. Okay.
Okay. So when we then the next we have studied simple harmonic motion. Okay. Simple harmonic motion is a just simple motion of spring from its mean position. Okay. What is the mean position of spring, Kevin?
That's when like x is 0.
X is 0 means the original length. Okay, x is 0 means the original length of the spring, that gives the mean position. Okay, when we pull it with some force, the spring it extend x x meter, and then when we leave it, it contracts back x meter. Okay. So when we pull it, there is a restoring force creates into the spring, that is F is equal to minus of kx. Okay. That is F is
Yeah,
equal to minus kx. That is the restoring force into the spring. Why it has minus direction? Why it has minus sign? Because the
it's going
restoring
back.
force is always opposite to the applied force. Always opposite to the applied force. Okay, that is the restoring force. So that is F is equal to k minus kx. That is called Hooke's law, and where k is spring constant or stiffness of the spring. Okay, of the material. Okay, of stiffness of the material. Okay, x is the distance displacement from equilibrium position. Got it?
Okay.
Okay, that is simple harmonic motion. Okay, amplitude, the maximum possible displacement, that is amplitude. Time period, when one oscillation is completed, that is time period. One oscillation, x is equal to 4a. That whatever you have written into the first question, that is total time taken to complete this one cycle is called time period. Okay.
Yeah.
Okay,
Okay.
then the frequency, that is fine. And this the vertical motions, simply just like the horizontal motions we have here, we have discussed the vertical motions of the spring. Okay, then we have done some questions. Okay, so till this now you got everything,
Yeah.
Kevin? Okay, so now the next point is, suppose if this is a spring. Okay, and this is the mass m of, this is a block of mass m. Suppose if I apply the force to this direction, okay, that is the force. If I apply to this direction, then in what direction will be the restoring force?
We'll go to the right.
It will go to the right, right? Okay, so when I will apply the force, spring will contract, right? Because I'm pushing the spring, right? When I'm
Yeah.
pushing the spring by the force, it will be compressed. So if it will be compressed, spring will oppose this applied force, right? It will, if it will oppose this, how? Then it will be, restoring force will be what? That will be in this direction, kx. Okay, and the amount of that will be kx. Okay, okay, okay.
Yeah.
The amount of this is kx, but when I write it, F is equal to what? See, F is equal to, so F is equal to that, the restoring force is minus kx. Because why minus? Because this is opposite to the applied force. This is F applied and this is F restoring. Okay, so what I'm writing, that is restoring. Don't be confused with F applied. Okay, F restoring is equal to minus x, and F applied is equal to kx. Why it equal to kx? One is kx and F applied is this direction, F applied. Okay, so since they both are equal, you can write it them with an equal sign. Okay, okay, okay. So that is just the introduction. Okay, now always remember that the SHM, like what type, how many, if I give you some examples of the type of motions, how will you differentiate that these are simple harmonic motion or not? Okay, what is the speciality of simple harmonic motion? F has to be minus the force restoring force. It is restoring. Always remember this, the restoring force has to be what? So from here, what we can conclude, F has to be proportional to x. Okay, and what x? Minus x. Okay, x is what? Where x is displacement from mean position. Okay, okay, Kevin.
Yeah. Okay.
Okay, so that is minus x. So always remember, when restoring force is proportional to the negative displacement, like negative direction of displacement, then that is what? That is the simple harmonic motion. That is the type of simple harmonic motion. Okay.
Okay.
Okay. So This is called simple harmonic oscillator as well. Okay, you called it SHM or simple harmonic oscillator. Okay, so suppose if I give you an example, f is equal to minus k of x square. Is this a type of SHM?
No, it's x is squared, so then then the distance will be different.
Okay, f is proportional to minus of x square. So this is not SHM. Okay, now tell me the second point. Tell me which are SHM and which are not SHM.
For the last two?
Yes, these three.
Oh, okay. They're all SHM
How?
because they're all inversely proportional to the distance.
Okay, inversely proportional or proportional?
Just proportional.
Okay, you say not proportional to the negative displacement, not just displacement. Okay, what is it? Minus sign,
Then
right?
yeah. So
F is
first
proportional to
one,
minus y. So is it SHM?
yeah,
Yes. Okay. Is this SHM?
no,
Why?
because it's not a negative distance.
It's not a negative displacement, not distance, negative displacement. Okay. F is proportional to minus theta. So it is SHM. Okay. You were saying why you were saying all three?
Because I thought f could also be proportional to the positive
No
displacement.
positive. Always remember negative displacement. Okay. The negative displacement and linear. Negative displacement and linear. This is called x to the power of 1. X to the power of 1, right? So linear displacement. Linear and I'm writing it here. Remember that. Linear and negative displacement. Right? Got it?
Okay. Okay.